Now, fuel cells is one of the separate science content questions. It is much more difficult, but if you follow your base principles, as we have always, and you follow your ions, you should be quite simple. Now, the first thing we have is if I have a word equation, for instance, copper sulfate plus magnesium goes to, if we remember, magnesium is more reactive than copper, so it will displace the sulfate, displace the copper to making magnesium sulfate plus copper. That would be my word equation. To make it my symbol equation, I'll have to use the symbols on the periodic table. So I will have copper sulfate, CuSO4, plus Mg goes to MgSO4 plus Cu. Now we're going to add one new layer of equation to this. Now, it's called an ionic equation. Now, an ionic equation is effectively, I remove anything that is a bystander ion. So I'm going to remove the bystander. So that is anything that doesn't change its charge, or spectator ion. Because what this does is it doesn't change. So if I look at this, copper starts off as 2+. Sulfate is 2-. Magnesium is 0. Magnesium now becomes 2+, so it's changed. Sulfate becomes 2-, so it doesn't change. And copper becomes 0, so it has changed. So in this situation, the only thing that has stayed the same, it's a bystander, is the sulfate. So I have Cu 2+ plus Mg, which is now neutral, 0, goes to Mg 2+ plus Cu. So now I've got to think about this. We go back to our ions and our ionic equations. Well, what has actually happened? Now, a really simple way of putting it is, I've put this Mg in my copper sulfate solution, and what's happened is I have my copper 2+ in solution, I have my Mg, and that Mg has quite literally given 2 electrons to my copper sulfate. Now, a fuel cell's largely the same, except I have my Mg here, I put a wire down it, and then it gives 2 electrons down that wire to my copper sulfate. That Mg, by giving 2 electrons, will therefore have to go into a solution of Mg2+, and this copper will turn into copper. Now, there is a very specific way that we have to design this. Let me just pause it for a second. So, with that before, we have the Mg giving the electrons and becoming Mg2+. So I need to have an area where I have magnesium solid and I have a solution of magnesium 2+. This then needs to be connected through to an area where I have copper and copper 2+. So this allows for the electrons to move from the magnesium through to the copper. When they hit the copper, they combine with the copper 2+ and make it larger. The magnesium will therefore move into the solution and become magnesium 2+. But there are certain things that we have to put in place. Now, first up, if I was to leave this, there would be suddenly a big build-up of negative charge as all of the electrons move down this side. and there'll be a big build-up of positive charge. So I have to put in a salt bridge. Now this salt bridge means that when the negative charge starts appearing on the positive charge starts appearing on this side, negative charge in my salt will move to balance it out. And also when the negative charges start appearing here, because the electrons are taking out the copper 2+, positive charges will move this way. Now typically they use potassium nitrate, because potassium is a very unreactive metal, nitrate is a very unreactive anion. So it's very unlikely that they're going to interact with either of these. Now to measure the last bit, which is our potential difference, we can quite simply put a voltmeter between them. That will give us a reading of maybe 2 volts. This is how you can measure the cell potentials between in a fuel cell. So we've already done half equations in electrolysis, but we can also do them here for each element. So my Mg will be becoming Mg2+. Now the only way it can become Mg2+ is if it gives 2 electrons to the other side, 2E-. The magnesium would therefore move from the Mg solid into the solution. On the other side, those electrons are added. So I have Cu2+ combining with the 2 electrons plus 2 electrons to make it copper solid.